All right, good evening, folks. I'm spent a little time working on some more factoring stuff now, and working through some examples on this. I had a couple off from the homework that I wanted to look at just to explain kind of what they were getting at. The way they asked the questions in the online homework was a little strange in some places, and I don't want to make too big a deal of that, but I want to explain what they're doing there and get some factoring practice out of that. I'm hoping to answer some questions on here. So if you're able to drop in, if you had some that you're stuck on, drop a note in here and I'd be glad to get to it. If there's anything from the lab that you're not sure about, I know the answer key is in there anyway, but if there's some of those where you're not getting the same answer, let me know. I'm going to turn this thing around so we can take a look at a piece of paper together and work on some factoring. And I want to get a lead into next week again. What does all this factoring do for us? There's one other big answer to that question. There's some actual equations that factoring makes it possible to turn complicated equations into simple ones that we can solve. I want to introduce that idea. I did it in the morning video, so if you already watched that, this would be a little redundant, but I'm going to go back through that zero factor property idea again, spend a little time on that. Hoping to have some questions to answer when we get into that. Okay, so I want to take a look at number 11 from the homework. It's a pretty challenging factoring problem. Also, the way that they asked it was a little bizarre. So I wanted to get to the bottom of that. And you might have different numbers on this, but this is the one that came up for me when I looked at question 11 on here. Really high powers on this one. Could throw you off. We don't usually see exponents that big, but we're looking at 81x to the 8th minus 25y to the 6th. So now we should look first for a GCF on that thing. It's always the first question you should ask. Although in this case, 81 and 25 don't have anything in common. And the letters, this is all x's and this is all y's, so there's nothing in common between these two. That's a different kind of factoring problem. Then we can't do anything with the GCF. GCF is 1 for these two things. So we have check, but nothing to pull out there. Now we're looking at it and we're just saying this is a two-term factoring problem. So the only other kind of factoring that could work is one of these forms that we have, our sum of cubes, difference of cubes, and difference of squares forms. These are not cubes that we're looking at. Well, the powers are 8 and 6, and the numbers happen to be perfect squares. And the exponents might not look like a perfect square to you because it's an 8 and a 6, but those kind of are perfect squares. This is leading into something we're going to look at in a later chapter, so let me spend a minute on that. When I call stuff perfect squares, what I mean is that something got squared and ended up as that, right? 81 is a perfect square because 9 squared is 81. And 16 is a perfect square because 4 squared is 16, right? Those are perfect square numbers. But when we get to letters, x squared is, of course, a perfect square. But higher powers can be also. I can write x to the 8th as something squared. Because of our exponent rule, if I put x to the 4th inside here, x to the 4th squared would be x to the 8th because we would multiply exponents. So anytime this is an even number up here, I can write it this way as something times 2. So it is a perfect square. Even if I had 22 over here, the number 22 is not a perfect square, but x to the 22nd is a perfect square because I can write this as something squared, x to the 11 squared. So that's what we have here. These are perfect squares. We're going to have to look at the exponents on that. So we're trying to write it this way as a difference of squares. And then we're going to be able to factor it using the difference of squares pattern, which has the minus and the plus there. Something squared is 81. This is going to be 9. Something squared is x to the 8th. This has got to be x to the 4th. And then this is 5y to the 3rd squared right there. So those are the pieces that I'm looking at. You can see that. Look. Those are perfect squares. So my pattern tells me that if I have those in a difference of squares, then my factors are the minus and the plus. 9x to the 4th minus 5y cubed, and 9x to the 4th plus 5y cubed. Now in the Lumen homework, it was asking for those factors as your answers, but it really doesn't matter which factor is which. So it's weirded a little strange because for computer entries, they have to have unique answer right there in these things for A and the B. And the answer looked like A, B, there's 2 blanks right there. Which one's A, which one's B? They had to have one way of distinguishing that. So it says in the problem, in the wording of the problem, A times, all right, this is a product of 2 polynomials, A times B, where the coefficient of y in A is greater than the coefficient of y in B. So we're comparing this number. This is the coefficient of the y term. And we want A to be the one that has the greater coefficient. So the plus is going to be part of the A factor. So they want this one for A. 9x to the 4th plus 5y cubed. And B, this has got to be the B here, 9x to the 4th minus 5y cubed. That's all. That was kind of strange wording. And it's a pretty strange factoring problem. But you'll experience looking at that pattern and using it. See you later. See what else we've got that's off from the homework there before I move on. I want to do a delete into the zero factor property thing. But let's see what else happens here. One toward the end of the homework now was question 14. This is factor completely. We always want to factor completely, but that's kind of a clue that maybe there's more than one step to it, more than one kind of factoring step to it when it says factor completely. We're going to start factoring, and then we're going to keep on factoring until we're done. And what that means here is, well, the same thing we always look for first, which is a GCF. We got to take care of that first, and then we got to go from there. So the one that came up for me on question 14, you might have different numbers here, but I have 2z to the 3rd minus 98z. And it should be something in that pattern that you get for number 14. There is a GCF to pull out, and that's what we got to do first before anything else. So we're looking at these things. 2 goes into 98, and 2 goes into 2, of course. So I can take a 2 out as part of the common factor. And I have z's on both terms, so I can take out just one z because that's as many as I have right here. What they have in common is 2z. So I want to factor that out. 2z to the 3rd divided by 2z leaves the z squared, the other z's. And 98z divided by 2z is just the number 49. Now we ask ourselves about regular factoring. It still has an exponent in it, so I have to think, can I factor this and split it up into pieces right here? And we can. This is a perfect square, and 49 is a perfect square. So that's 7 squared. So I can write this using my difference of squares pattern as z minus z and z plus. Sorry, z minus 7 and z plus 7. That's a little hard to say. But those are the factors on that, along with the GCF that's still there. So that's the factored completely form that they're looking for there. And they just wanted that written out. So the order of the factors doesn't matter there. They should be okay how they have that written. But it should be separated out into all 3 of those factors. These numbers weren't perfect squares to begin with, but that doesn't matter. It's after the GCF that's pulled out that we look at the other kinds of factoring. So you're looking for either squares or cubes if you're trying to use one of those factors on, or one of those forms on a problem like that. After the GCF is pulled out, that we worry about any of the other kind of factoring. Now we're going to be moving on with the start of next week's work. We're going to be moving on with it's called rational expressions. We also want to look at some equations. If you're super good at factoring, then both of those things are going to be pretty manageable, because a lot of the work in these problems is getting them factored properly, getting them written in factored form correctly to start the problem, or along the way in the problem. That's the key step to these. So if you're really good at factoring, this should go a lot better for you. And if you're not really good at factoring yet, you're going to get a lot more practice, because it's part of the process that we're doing in the rest of these problems. Factoring along the way is part of what we have to do. I want to see how it applies to the equations first of all. So going into new stuff, there's a principle called the zero factor property. And I'm going to write those on separate lines, because they also describe separate steps of solving an equation right here. The zero factor property is talking about factors of zero. We haven't looked at numbers that multiply to zero, because we haven't run into zeros and the other kinds of factoring that we're trying to do. But if you multiply two things and you get an answer of zero, well, the only way that could happen is if one of the numbers is zero. This could be 0 times -7, it would come out, or it could be 11 times 0, or whatever the other number is, doesn't matter. But one of them does have to be 0. We can't get that answer unless one of those factors is 0. And that's the idea. It's called the zero factor property, but here's how we're going to apply it in an equation. Moving through that a little quicker. But if I want to find out when 2x squared minus 11 is equal to, well, let me think this through. I'm trying to make up a problem now, and let me think this through to make sure I've got a good handle on it. That didn't come out nice. Let me do it this way instead. 2x squared minus 11x equals -12. That's my equation. Sort of a dramatic pause there while I think of a problem that's going to come out. Right. 2x squared minus 11x equals -12. So it's not obvious what value of x would make that thing true. It's not obvious to me anyway. So, and the other thing to think about here is I could push things around, but I'm not going to be able to just get x by itself by doing my normal doing stuff to both sides here, because I have an x squared term and I have an x term. They both have x in them. So I can't isolate either of those things without getting rid of the other one. And they're not like terms because of the exponent. So the usual stuff for solving for x is not gonna work here. And you could write this another way if you're thinking in terms of factoring. You realize you have an x as a common factor here. So this thing that I have on the left side could be rewritten this way. But that still doesn't help me at all with knowing what the actual values are here, because two numbers multiplying to -12, there's lots of ways that could happen. I don't know what either of those numbers are if I have a -12 sitting here. That doesn't help me. So I'm going to forget about that, doing that, and I'm going to deal with a 0. I want the equal 0 on the other side, so I'm going to add 12 to both sides and write this equation with a 0 on one side. That's what this step would turn into. 2x squared minus 11x plus 12 is equal to 0. You can always do that with an equation. If you have some terms in it, you can always add and subtract stuff until you get 0 on one side. That's not hard to do, and that's the key to this thing. If it's equal to 0 and I can factor it, then I can use this idea that means one of the factors has to be equal to 0. So the first thing is to get to 0, and the second thing is to factor it. We actually do the factoring on that. I'm just going to write these down because I think I can work out these factors okay without too much trouble here. These are going to both be minus. We're looking at -4 and -3. So you have to think about where those factors came from. I did that without really going through the steps there, but that's what you'll end up with for factors of that thing. It does factor, and those are the factors. And they multiply to 0, and this fact is telling me that the only way I can get 0 is if one of the pieces is equal to 0. So the property tells me then that either 2x minus 3 is equal to 0 or x minus 4 is equal to 0. So that's where the property comes in. It enables us to take this complicated equation and turn it into two very simple equations. Factoring helped us to do that. And whatever works here, which is, of course, x equals 4 would be the solution to this. It's going to make that equal to 0. That's going to make this equal to 0. So that's going to be a solution to the original equation. Both of them are. The other one says 2x minus 3 is equal to 0. So 2x equals 3, or x equals 3/2. That's the solution of this one. Both of those are going to result in a 0 here. So both of them are going to work in that original equation. I got two solutions to it. So that 0 factor property turns your equation, your big equation, into a bunch of little equations. And you get oftentimes two solutions to that, maybe more, because each factor is going to give you a solution on there. So we could get equations with multiple solutions. That way they're often going to have 2, sometimes 3 solutions to them. I don't think I have anybody out there watching this live. Doesn't look like it. So I'm trying to make this useful. The next thing we're going to see is this 0 factor property, and then start some work on rational expressions. We'll try to get into that. So another place where we really care about factors, try to move through this quickly. Give a little bit of a lead in to where we're headed next. Another place where we're going to worry about factors is in simplifying fractions. If I'm looking at something like 18 over 24, and just being able to write that in simplest form, I can do this by dividing if I want to think about division, but what we're heading toward here is having great big polynomials up here, stuff like this. And so we don't want to think about division. We did a little division with polynomials, but it's not the easiest thing in the world to do. We don't want to think about it that way. So instead of thinking about what I can divide these by, I'm going to think about factoring them and then simplify it that way. 18 is 2 times 9, which can be broken down if I want to factor it completely. It's 2 times 3 times 3. And 24 is 2 times 12, or 2 times 2 times 3. No. 2 times 2 times 6. So I can break it up completely this way. It's the completely factored form of 24. And the reason for writing it that way is that my division can be done this way. I'm just getting rid of common factors for that. So the simplified form is just 3/4. I kind of did division right there, but I'm just dividing something by itself. So I made the division very easy by writing it in factored form and just canceling common factors from the top and bottom. And I got the simplest form. That 3 and 4 don't have any common factors anymore. So 3/4 is the simplified form. That's how we're going to want to think about this when we're doing rational expressions. We might get an answer like this, and we want to write our answer in simplest form. So we're going to have to think about, is there any common factors to this thing? There's terms that look alike and terms that are close to each other right here, but common terms doesn't help us at all, because the only thing we can cancel here is factors. We have to divide stuff. So it has to be written in factored form in order for any of that to help us. So we have to think about the factors of those. Again, not going to go through all the steps on this. I'm just going to write what you would end up with if you do the factoring there. By now, you can probably look at that and think about the factors. This one's a little bit more challenging, but these aren't hard factoring problems. All the numbers here are going to be x plus 5 and x plus 3. That's what you would end up with in factored form. And then you can tell easily the simplifying. There's nothing to it. You just look for common factors to the numerator and denominator. And whatever you got left, that's your simplified form. All the common factors are gone. So x plus 1 over x plus 5. It's the same value as this, except it's written in a much nicer form. That's what we're trying to do with those. And even with multiplication problems, there's not much more to it other than doing the factoring on there. So if I need to multiply x over x plus 4 times x squared minus 16 over 5x, I got to think about how multiplying fractions works. So again, let me make the analogy back to arithmetic out there. Multiplying fractions isn't hard with numbers, right? Well, maybe it's harder for some people than it is for others. But if we have a couple of fractions like that, we're going to multiply 5 times 3 and 7 times 11, right? This stuff on top just stays on the top. So essentially, we're just doing this. Just making it into one big fraction. Put these together and put these together. And then we'd have to think about, is there any common factors right here? But we can tell, since we had them separated out, there isn't any common factors there. That's the simplest form of that. They really just do go together like this. We're going to do the same thing with, these are called rational expressions. That's what we're dealing with in the next chapter here. These kind of expressions where we have polynomials on the top and on the bottom of these fraction things, rational expressions. So I'm just going to think of them this way. And that's all one big fraction now. The only question is, there's your answer. The only question is that answer in simplest form? And that's a question that we got to think about factors to know. So I'm going to rewrite stuff using the factors of it. X is kind of there by itself. X squared minus 16 should factor out. 16 is 4 squared, so this is x minus 4 and x plus 4. We do use that difference of squares pattern a lot. X plus 4 is already sitting here. That's already done. 5x, well, that's 5 times x. Those are separate factors, so I could write them this way. That's multiplied. And then I can see, indeed, there is some factors that are in common. So I can cancel common factors from this. I can cancel common factors here. And the simplified form of that answer comes out pretty simple. Goes out pretty short right there. The factors have to match in order for this to apply. We have to have matching factors, but a lot of these things will, because we're making up algebra problems to illustrate this principle. So of course we're going to have some common factors in there sometimes, and your job is to find them. So being good at writing things in factored form is a lot of the work. In fact, that's all the work. We're just crossing stuff off from there. We're just whittling it down from there to see what you got left. That's the idea of multiplying rational expressions, and that's the first thing we want to be able to do that. That's all. Multiplying rational expressions works. I got a little time here. I don't question the answer. So I'm going to lead into dividing rational expressions also. I want to see what happens with division on this. It's actually Not much more work. There's one additional step when we're doing dividing irrational expressions. So, sounds scarier, but it's not. And again, if you remember how fractions work with numbers in there, same kind of things going on. But that's usually an analogy that doesn't get a whole lot of mileage because people aren't super good at fraction operations usually when they start into algebra. And here's where we work some more with that. But dividing fractions, well, dividing in general, I'm going to make it black. Use the other marker. Dividing is multiplying by the reciprocal. So we're going to turn this into multiplying problems, but it's multiplying by the reciprocal, which is what precise language that math teachers use to describe this thing, but the reciprocal of this is what we need. And the reciprocal is of a fraction is just flipping that fraction over. That's really all that happens. If you had to do a number divided by 3/4, that's asking how many 3/4 fit into 6, which isn't too obvious. You could draw some pictures right there. But the fact is the easy way to do that problem is to rewrite it as a multiplication by 4/3. And then hopefully you recognize the common factor there. You're just going to get 8. It takes 8 3/4 things to make up 6. 8 times 3/4 is equal to 6. So that's the answer there. And the easy way to get it is not to think about division, but to turn it into a multiplication problem. And the reciprocal is real easy right here for a fraction. So that's what we're going to do if we're trying to divide polynomials, divide rational expressions. I mean, we're going to look at a division problem. We're just going to turn it into a multiplying problem, and whatever the numerator and denominator are, we're going to flip that around. So I have x minus 5 over x minus 7 for one of these things. And then I'm trying to do a division problem. And this is going to have terrible example. Let me start one over. Doing this live. I'm trying to think of examples because I didn't have a book open in front of me to take these things out of. But I don't want to do that one. I want to do a division problem. There's a little bit of factoring to be done in there. Here's something with a little bit bigger numbers that we can do a factoring problem on. But if I recognize that as a dividing problem, this is certainly dividing these rational expressions. And we want to turn it into a multiplication problem by multiplying by the reciprocal. So I'm going to rewrite this first one exactly the same, except I'm going to put containers around those because those are factors. That one stays the same, but I got to do the reciprocal of this one. So in the process of writing this in factored form, I'm also going to do the reciprocal right here, that this is dividing by this thing is multiplying by 3x minus 21 over that big thing. But I'm going to go ahead and write this in factored form while I'm at it. 3x minus 21 looks like a simple factor, but there's a common factor of 3 that should be pulled out. That's the factored form of it. This looks complicated, but it looks like something that ought to factor, right? So we have to think about x squared minus 16x plus 55. Your number in the diagonal there would be 55, and we need factors that add up to negative 16. We need numbers that add up to negative 16 there for the x terms. So I must have negative numbers for the values here. There's not too many things that go into 55. Actually, there's not very many. And there's one that adds up to negative 16. So negative 5 and negative 11 are the factors here. And that's actually what I end up with for coming out of the rows and columns there. So that's my factors to this: x minus 11, and x minus 5. Did that factoring pretty quickly. But you see that writing that thing in factored form and rewriting the division as a multiplication by the reciprocal made this really easy to do. Now my multiplication is done by this. Boom, it's multiplied. The only thing is to write that answer in simplest form, and that's where I do a little bit more, cross some stuff off, right? Those match. Doesn't matter which one they came from because it's all one big fraction now. And the x minus 7 also matches, so this did simplify an awful lot. I got 3 over x minus 11 as the simplified form of the answer. Probably should work through a couple of those, and I probably should, rather than trying to make these things up on the spot, I should just jump and grab some from the textbook here because we do have a section on that. I think I closed this chapter, but I'm going to grab it, open it back up here. Textbook chapters. So in our textbook, we're moving into chapter 7, multiply and divide rational expressions. We're going to get through that part of it, and then we've got to take the test, mostly on the factoring and this early rational expression stuff. We're keeping the test at the end of next week. So I'm going to do multiplying and dividing. I'm going to do some of the simpler stuff with rational expressions. Then we're going to stop. We're going to pick up times to take this test, and at the end of next week, you'll have some time slots to choose from to take the test. After the test is over, we're going to do a little bit more complicated stuff with rational expressions, and then move on from there. There's radicals after that we have to get to. These are coming out of section 7.1 in the textbook. Then I want to grab a couple of these division problems to work it through. They can be written a couple different ways. We're going to work through division anyway. A couple of different things happen. So this is coming from textbook. I'm going to do number 49. Strange division problem because one of them doesn't look like a fraction to start with. So 49 is x squared plus 3x minus 10 over 4x divided by 2x squared plus 20x plus 50. Now that's not actually a fraction in that. It's just a big polynomial over here that I'm dividing by. But I'm still going to do that as multiplying by the reciprocal. So how do I flip something over if there's only a thing there and not a denominator? Well, there is a denominator. Right? You're going to think of this as over 1. That's what you did with whole numbers when you're doing fraction operations with numbers. Same idea here. This thing is itself over 1. So I can multiply by the reciprocal of that. It's going to be 1 over that thing. But so this one stays for x. This one, I'm going to rewrite it in factored form, but the reciprocal happens over here, and I got to write that in factored form also. So I got to think about the factors of that. This one stays on top. The factors of this one, pretty easy. I'm just going to write those down. Factoring here, I have a little bit more work to do, and I don't want to neglect a nice opportunity to do another factoring practice problem, especially when there's a trick to it here. So if you're thinking x and 2x, you're off to the wrong start here because there's a GCF to pull out. Notice it's always the first thing we should look for. I don't always mention it, but if there is a common factor to all of them, we got to pull that out first. We got a common factor of 2. And then this is just x squared plus 10x plus 25. So for one thing, we got one of the factors already. And for another thing, this looks a lot easier to factor now because that 2 is out of the way. We got smaller numbers. Sure enough, this factors into x plus 5, x plus 5. And so those are the factored forms. And I did my reciprocal, so this is now a multiplication problem, which means it's now just one great big fraction. and I want a simplest form of that for the answer. Now you don't necessarily have anything that will cancel, but oftentimes you will, and you want to get it in simplest form if you do. Here it's an x plus 5 with one of those. That's a pair of x plus 5s on the top and bottom. So that simplifies out. The top is now just x minus 2 times 1. And the bottom is now 4x 2 x plus 5. I have enough stuff there that I want to kind of put this together. The result, I'm off the screen here. Top came out kind of nice. This is a bunch of stuff. I couldn't get it all multiplied out. I'm at least going to put together all this stuff out here as 8x, x plus 5. I could go ahead and write it as, distribute it and write this as 8x squared plus 40x. That's another way of writing that answer. This is factored and expanded form of that. They're not really different. It's just two different ways of writing it. So either of those could be perfectly all right as the answer. We do have to make sure it's in simplest form, but that just means that we got rid of those common factors that are there. There's no more common factors to this to take out. All right, this is going to end up being a video that hopefully people are watching later because I don't have anything going on with it right now. So I'm going to keep this kind of a nice size. This will be a good little intro to the stuff that we're dealing with first part of next week. In my email on Monday, I'll have some time slots there for you to choose from. You got to pick a time, take the test, and it'll be on factoring and solving equations by the zero factor property and multiplying and dividing rational expressions. We're going to get that into the first part of next week. So details will come out on Monday. It's a good intro to it if you get a chance to watch this. I'll get homework up on the multiplying and dividing with these things. I'll get that up shortly also. So I'll have a good weekend.